Right, we're in 9.5, continuing our focus on roots and radicals. Now we're going to talk about radical equations. In other words, when we're solving for x and there's a radical involved. So let's just do a little bit of review here to get ready for this section. Solving for x means that we want to get x alone. We've been doing this practically from the beginning in algebra. That's the goal here, is to find out what x is. And the way we've always done that is to undo what's happening to x. And this is how I teach solving equations in Math 60. And if that's something that still is a little shaky or unsure for you, I'd love to give you some extra help in class, one-on-one, get you paired up with a tutor, office hours, whatever it takes. But this idea that we undo what's happening to x is going to come in handy when we need to get rid of the radicals in order to get x alone. So we need the opposite operation. When you undo it, you need the opposite operation. So what we have, or what we're going to see in these equations, are radical x, roots. And the opposite of that is exponents, specifically squaring, because this is the square root. So we're going to utilize squaring as the opposite. So it's taking the square root of something, we're going to raise it back to the exponent of 2. So let's look at the steps that are involved here. These are on your notes. Step 1, get the radical all by itself. Remember, our goal is to get x all by itself, but we kind of have to take this in steps. So first we need to just get the radical. Even if there's x's elsewhere in the equation, your goal becomes get the radical all by itself. Then we're going to square both sides. So we're going to just take the whole thing on each side, put it in parentheses, and square both sides. What this will do, it will undo the radical, and then what we'll get is an equation that we're able to solve. And those will take on different forms, but we have the tools to solve them. They might be a quadratic that we end up having to solve, might be a simple 1 or 2 step equation to solve, but we'll be able to solve it. This next part becomes really important. Sometimes we get so good at algebra at this point that we forget to check our answers. But at this point, it is really, really important that we check each of our answers back in the original equation, because it's very possible that we could come up with extraneous solutions. We mentioned these earlier in the chapter. An extraneous solution is an answer that you get that does not work in the equation. So an extraneous solution is an answer that you get doing the correct algebra. So it's a correct algebraic answer. You've solved it correctly. You didn't make a mistake. But when you plug it in, it does not work back in the original. So it's a solution, but it's an extraneous. It's not one that we can utilize. So let's look at this. Let's look at number 10. We're starting with radical 5x minus 6 equals 8. And again, our goal here, as soon as you see a radical in an equation, we're going to start by getting the radical all alone on one side. And in this case, that's done for us because we've got everything under the radical. There's nothing being added or subtracted. It's just fine just by itself. And we've got it equal to 8. Okay? So the next thing we're going to do, step 1's taken care of for us. Next thing we're going to do is we're going to square both sides of the equation. So we're going to take that entire thing and square both sides. So we're going to get, if you can imagine rewriting what we've got here, 5x minus 6 equals 8, just to make it clear on the notes for later what happened. We're just going to square both sides. Now, the point of squaring is to undo the radical. So you aren't going to touch anything inside. All it does, the only job here, is the square undoes the radical. So the square takes away the radical and it's done its job here, leaving behind just the 5x minus 6. And over here the square does its job by saying 8 times 8 is 64. So very important that you note that that's what happens. You aren't doing anything to what's inside the radical. You're just removing the radical itself by undoing with the opposite operation. Now from here, so this is what's new here. This is the new steps right here. But from here on out, this is old stuff. This is what we already know how to do. Okay. From here, once you've created the equation, once you've gotten rid of the radical, you should be able to recognize and solve these equations. So adding 6 to both sides, we get 5x is equal to 70. Dividing both sides by 5, we get x is equal to 14. Very critical that you check back in the original. So we go back to our original. It was 5x minus 6. And we are checking that x value of 14 where the original x showed up, and we're just making a note for ourselves, does this work? 5 times 14 is 70. 70 minus 6 is 64. Square root of 64 is indeed positive 8. So it does work. So it checks out. So our answer is x equals 14. And I kind of ran out of room here, but that would be our answer here of x equals 14. Try to make better use of the space as we go along here. So those are the steps. Get the radical alone, square both sides, solve the equation, check it back in the original equation, because sometimes you might get an extraneous solution. You did the algebra just fine, but it might not work back in the original. And again, just to highlight, the only new thing we're adding here is getting the radical alone and then squaring both sides. Everything that follows that is stuff we should recognize and know how to do. Let's try some examples at the bottom of the page.